Now, when you start this question, you should think this almost looks like the definition of derivative, but it's not. Okay? When something almost looks like something else that you know of, you have to try to make it look like the proper thing. That's what it's supposed to look like. Okay? So we have to make this look like a derivative. Now let me just write that here. F inverse at x limit h approaches to 0, f at x plus h minus f at x all over h. Okay, all over h is a derivative at x. Now, instead of h, just 3h's, the 3h, that should be the thing that's confusing you. Okay. So how do I resolve this issue? Instead of h, there's 3h here. Now, it's still gonna be, so h is approaching 0. If you replace that with, let's say, 3h, and replace the bottom with 3h, right? And if h is approaching 0, you can replace that with also 3h is approaching 0. This will also equal to f prime at x. If you think about it, h is just some small random number, right? That's approaching 0. The key factor here that's important to be the derivative of x, derivative of the function at x, is that this decreases to 0 at the same rate. That's the key. Okay, if you understand that, I have this here, okay? I have 2 plus 3h. Okay, if I have f at 2 here, okay, and instead of h, what I need is 3h, isn't it? Right? Of course, I just right now randomly divided by 3, and I randomly introduce the subtraction of minus f at 2. So I gotta actually do this. Now, if you add these two, it's actually 0, right? Okay. At the back, let me keep it the same. Okay, I need 3h, so let me put 3h there. And in exchange, let me multiply this whole thing by 3. So multiply by 3, divide by 3. Really, I didn't do anything, right? Okay. So hopefully you agree with that. So we have f at 2 plus 3h minus f at 2 all over 3h. I'm separating this part now. Because I mean, the whole reason why I did what I did is because if I separate like that, it becomes a derivative. What's left over is f at 2. So I want to keep in the same format. So what I'm going to do is factor out a negative 1. I can write this. Also 3h. Okay. Now this 3h though, I don't want 3h here. I want here, but I don't want it there. So what I do is think of it like this. Not the same thing. Okay. Now if you take the limit, so if we apply the limit to this expression and that expression, what we get is 3 times by f prime at 2 minus 1 over 3 f prime at 2. Okay, that right there is f prime. This is also f prime.
Yeah, hold up.
Alright, so David is still, you're suspecting they perhaps might be different. Why are they same? Okay, so let me draw a nice picture for you. See if I can explain this. Let's say here's my function, okay? This is 2, okay? And 3, so let's say 3h. 3h is here. So do you see that in this case, so here, that divided by this, so let's call it delta y over delta x. Delta y over delta x. Okay, that's equal to this part here. Right. This is exactly. Let's call this part here a. Okay, so a is equal to that. True. Now, this one here, we're shrinking instead of 3h. So instead of saying 2 plus 3h, it's just h. So exactly a third. Okay. So that and that now, right? Okay, so let me call that like. So you're right. Right now, it's different. This is smaller. Well, actually, is it smaller? The top and bottom is smaller. The delta y and delta x is smaller. But the ratio isn't necessarily smaller. Okay, here's another fact that's really important. We're considering the ratio as delta x. So as delta x, in other words, as h approaches 0, this is definitely approaching 0 slower than this one. But where are they both going? They're both going towards the tangent slope. Okay, the tangent slope at 2. What is that? That is the derivative at 2, isn't it? Right? One's going a little bit slower. Now, it's not good. Let's say I have, like, up here I have f at 2 plus 3h. That means I'm finding the height here. Okay, I found the height here. And then f at 2 means so this height, right? So the problem before, in the beginning of the question, we had over h. So that means we're doing this divided by that. That divided by that. So the comparison between these two, there's no guarantee that as delta x approaches to 0, there's no guarantee that'll approach that instantaneous tangent. That's a problem, right? So that's why I made it that over this whole thing by forcing it to be 3h. But now, this over this, as well as this over that, okay, as well as that part over that, they're both approaching the derivative at 2. Okay, so I hope you're convinced that now this is 2 times 2 over 3 f prime at 2. So let's just differentiate this, right? Okay, so this is 2 times. Let's differentiate that, and you get 3 over 4 x squared minus 4 over 3 x, and you gotta replace the x with 2's. Let me multiply 2 in, you get 3 over 2 squared minus 8 over 3 times 2. So what is that? 6 minus 16 over 3. 18 minus 16 over 3, right? So the slope, or this value, is exactly 2 over 3.